In the last lesson, you understood how cloud services are delivered through IaaS, PaaS, and SaaS. You saw what cloud gives you. But now let's go deeper. What actually happens inside the cloud? What powers cloud computing behind the scenes? Because every time you upload a file, open an app, or stream a video, something incredible happens in milliseconds. A complete system activates instantly, from your device to the internet to powerful cloud systems and back to you. Let's break that journey down. User to internet, to cloud network, to compute, to storage, to response. All of this happens in milliseconds. Thousands of operations, perfectly coordinated. And it all starts with one powerful concept: virtualization. Imagine you have one physical server. Traditionally, that server could run only one system or one application. But cloud changed that completely. With virtualization, one physical machine can act like multiple machines. Here's how it works. A physical server runs a hypervisor, and that hypervisor creates multiple virtual machines. A hypervisor is a special software layer that sits on top of the physical hardware and divides it into several virtual environments. So instead of one server, you now have many virtual machines running independently. Each one can run its own operating system, its own applications, and handle its own workload. Think of it like a big building divided into multiple apartments. Each apartment has different people and different activities, but all exist inside the same structure. That's exactly what virtualization does. It makes cloud scalable, efficient, and cost-effective. But there's one challenge. Virtual machines are powerful, but they are also heavy. Each virtual machine requires its own operating system, which consumes time, memory, and resources. So the cloud evolved again. To make applications faster and more efficient, containers were introduced. Let's compare. A virtual machine includes the application and a full operating system. A container includes only the application while sharing the operating system. Instead of creating a full system every time, containers package the application along with its required libraries and dependencies. No extra operating system. No unnecessary overhead. That makes containers lightweight, fast, and portable, which means your application can run anywhere without breaking or changing behavior. Whether it is your laptop, a testing server, or a cloud environment, it works the same. This is what makes modern cloud applications so flexible. And one of the most popular tools powering containers is Docker. Containers made deployment faster, but cloud still needed a reliable way to store data, because apps are nothing without data.
Now let's talk about storage. When you upload a file to the cloud, where does it actually go? Is it stored in one server? No. Your data is distributed across multiple servers. Here's what happens. You upload a file. The cloud splits it into parts, creates multiple copies, and stores them across different locations. This ensures high availability, fault tolerance, and faster access. Even if one server fails, your data is still safe and accessible from other servers. So instead of relying on a single point, cloud creates a network of storage systems working together. Think of it like keeping copies of important documents in multiple lockers across different cities. Even if one locker is lost, you still have access to your data. That is the power of distributed storage. But storing data is only part of the story. Now comes the question:
How does your request reach the right server? That's where networking and load balancing come in. Every time you open an app, millions of users might be doing the same thing at the same time. So how does the cloud handle that traffic? Here is the flow. User request goes to a load balancer and then gets distributed across multiple servers. A load balancer acts like a traffic controller. Instead of sending all requests to one server, it distributes them intelligently across multiple servers. This prevents overload and ensures smooth performance. Think of it like a traffic signal at a busy intersection. Instead of sending all cars into one lane, it splits traffic into multiple lanes so everything keeps moving efficiently. This is why apps don't crash even when millions of users are online, because cloud handles traffic smartly in real time. Now imagine something even more advanced. What if you didn't have to manage servers at all? That's where serverless computing comes in. In serverless computing, an event triggers code. The code runs instantly and you get the output. You simply write your code. And whenever an event happens, like a button click or a file upload, your code runs instantly. No server setup, no infrastructure management. The cloud takes care of everything behind the scenes. You focus only on logic, and the cloud handles execution. It is like ordering food. You don't cook. You don't manage the kitchen. You just place the order and it gets delivered. That is serverless. Now let's connect everything. Every time you interact with an app, the flow is simple on the surface, but powerful underneath. User to network to compute to storage to response. Virtualization creates flexible systems. Containers make applications fast and portable. Distributed storage keeps your data safe. Networking ensures smooth communication. Serverless removes infrastructure complexity. All of these technologies work together in perfect synchronization to deliver your experience in milliseconds. What feels simple on the surface is actually a highly advanced system underneath. Now you don't just use the cloud, you understand what powers it. And that understanding is what separates beginners from real cloud professionals. But before we move ahead, it is time to test your understanding. Get ready for the Lesson 3 quiz and see how well you have understood what really happens inside the cloud. After that, we will move to the next lesson.